So today we're going to talk about qualitative data and how we can graph this data using the qualitative data. So data in statistics is often organized using a frequency table. A frequency table is a table that lists the possible values of a variable and the frequency that each of those possible values occurs. In a relative frequency table, an additional column is added to display the relative frequency of each value of the variable. So the data that we're going to look at today is data from a small bag of M&Ms. And so there are different colors in the M&M bags, and they break it down by color. So there were 7 red M&Ms, 3 yellow M&Ms, 7 green M&Ms, 11 blue M&Ms, 2 brown M&Ms, and 14 orange M&Ms. We will use this information below. So it's asking us to create a frequency table and a relative frequency table for the color of M&Ms. So we are going to have a couple different columns here. The first one is going to be sort of what we're looking at, right? So we're looking at the different colors. So I'm going to just sort of draw this over here. So we have colors, right? So we have, let's see what we have. We have red. We have yellow, green, blue, brown, and orange, right? So listing out all of our colors. It wants us to write a frequency table and relative frequency table. So the second column is going to correspond to the frequency. So I can fill that in, right? So if I think I had 7 red, 3 yellow, 7 green, 11 blue, 2 brown, and 14 orange. And again, I'm just getting that from the above information that they gave me. Okay, so we could total up how many M&Ms we had in this bag, right? So if I added the total frequency, the 7 plus 3 plus 7 plus 11, 2, and 14, and I sort of do, I'm running out of room here, but that should give me those 44 M&Ms. And so my last column would be my relative frequency. So relative frequency. And so relative frequency, we do need to know the total. That's why I had us calculate that. The relative frequency takes the frequency of the individual, in this case color, and divides it by the total. So we have 7 out of 44. If you want to grab your calculators and calculate this with me, right? So if we take 7 divided by 44, rounded to 3 decimal places, we get roughly 0.15. And so that would be my relative frequency. Relative frequency can be listed as a fraction or a decimal. So either way would be okay. So my next category would be 3 out of 44, or roughly 0.068. Right, 7 out of 44, we actually already calculated this right above. So 0.159. 11 out of 44. So again, if you just want to calculate this with me, right, that would be 0.25. 2 divided by 44, right, that's going to be a pretty small decimal, 0.045. And then 14 out of 44. And that should give me 0.318. Now, as long as I did this correctly, it should add up, if you add up all the decimals, roughly to 1. And I say roughly, sometimes it's a little bit less than 1. It could even be a little bit more than 1, just with some rounding errors. But, and sometimes it's exactly 1. It just sort of depends on the data and what you're doing. But that would be my frequency table, lists all the frequency of the different colors, and then my relative frequency. So that's one way we can display the data. In terms of graphs, there's a couple graphs we can create. So the first one being a pie chart. So pie charts are circular graphs. Sometimes some books use their circle graphs. But they're divided into slices that are proportional to the relative frequency for each possible value of the variable. So it's asking us to draw a pie chart for the color of M&M's data set, and then it has a question that we'll talk about in a minute. But if I look at this pie chart, right? So I have the circle. We want to think about creating basically each piece for the different colors. So let's see. I'm going to look at, I usually start with the largest percentage. Now, relative frequency can be easily turned into a percentage if we multiply by 100. What I mean by that, and let me change sort of the color of my pen here, right? I could say 0.25, right, is basically equivalent to 25%. And that's what we would want to put in my pie chart. So again, it may be helpful if you just want to change each of these decimals, let me go back, into a percent to help you graph. 15.9%, we have the 4.5%, and 31.8%. Okay, so let's see. I know, right, 25%, that's going to be exactly right a quarter. So if I draw sort of my middle point here, right, so I'd have a perfect sort of fourth. Again, sort of due to human error a little bit. But this would be blue, right, and it would be 25%. So now I have, right, 31.8%, so a little bit more than that. So maybe I'm going to do maybe something like that. And that's going to be orange. So we label the color and then we label it as a percentage. I have, right, the 15 percentages. So let's see. I have maybe over here. Again, they're not quite perfectly, but just due to some human error. So 15.9%, and then the other one was red. 15.9%, and then I have, right, my last two categories, and I might actually, since I can erase sort of easily, let me do a little bit of better job. These maybe aren't quite 15%. So you just want to, again, sort of your best approximation here. More like that. So that's why I'll do red as 15.9% and green is 15.9%. And so my last little bit, I have the 6.8 and 4.5. So 6.8, so yellow, 8%, and my brown is 4.5%. Okay, so trying to piece each of the little sectors together. We usually like to create a title for our chart. I know this one's a little bit, there's not much room, but we could say, right, the color of M&Ms. So I'll label that on the bottom, just so the reader knows what the graph's about. So if we look at the question, it says if you had 85 M&Ms, how many would you expect to be orange? So I have, right, 85 total. So if this distribution is true to the colors, we would look at orange, right? Orange had 31.8%. So we would expect that out of these 85 M&Ms, 31.8% would be roughly orange. So I would take my 85, I'd convert the 31.8% back into a decimal, so 0.318, and I would multiply. And so if you do this, 318, you get roughly, right, 27.03, but we can't really have a decimal, right, of M&M. So we'd say roughly, we would expect 27 of the 85 to be orange in our bag. And you could actually go through to do this for each of the colors if it had asked, so that you could see the breakup of the different distribution of colors for this 85 M&Ms. So that would be a pie chart, how we could display qualitative data. Another way we could display data is with bar graphs. So bar graphs, let me scroll up here a little. So bar graphs are graphs for qualitative data where the horizontal axis represents the possible data values and the vertical axis represents frequency or relative frequency. Each possible value of a variable usually has its own bar. All right, so Some key features of a bar graph. We have some equal spacing on each axis. Bars are the same width. There should be labels on each axis and a title for the graph. There should be a scaling on the frequency axis, and the category should be listed on the category axis. And again, the bars shouldn't touch in this case. So we're going to create a bar graph for the color of M&M's data set. So I am going to have a vertical and a horizontal axis. My vertical axis is going to represent for the frequency of the M&Ms. And then the horizontal axis is going to be the M&M color. So we had, right, from before, red, yellow, green, blue, brown, and orange. So here's all the different colors. And if we, let me scroll up just for a minute. If we look back at our frequency, right, the largest frequency was blue, orange, which had the 14. So we want to think of a good tally mark to go by, right, that will go up to at least 14. So 2s might be good. So I'd have 2, 4, 6, 8, 10, 12, and 14. So whatever you go by, you do want to be consistent. And so if you look back at the data, they said we had 7 red. So what I want to do is I want to draw a box roughly at 7 for red. And so each of my boxes from here on out should have that roughly same width. Again, I know due to human error it might not be exact, but they should look approximately. So yellow, there was 3. So I'm going to go and say, okay, well, yellow was 3. And some graphs will label above, some won't. It's totally up to you. Green was 7. So again, should roughly be the same height of the one in red. 7. The blue was 11. So let's see, 11 would be roughly here. I'm trying to sort of have the same width. Brown was 2. A little bit, that looks more like 3. So 2. And then my orange was that 14. 13. And then again, sort of put a title. So color of M&Ms. All right. So we could do this with a frequency. Sometimes we'll do maybe a relative frequency. We'll talk more about relative frequency on the next chapter, but that would be a bar graph. Our last type of graph that we can talk about is what we call a Pareto chart. And it looks very similar to what we just graphed above, but a Pareto chart sorts the data from left to right, from highest frequency to lowest frequency. So in this case, we'd want the highest frequency, or orange, to go first, and then blue, red, green, yellow, and so forth. So you can see which color sort of had the most. So we're going to all basically almost duplicate this graph here. Really the only difference will be just the way we order them. So we'll still have our frequency. We can still go by 2s. 2, 4, 8, 10, 15. And then we just want to arrange the colors. So we have orange would go first. And then we'd have blue. We would have red and then green. Or you could have green and then red since they're the same. And then yellow. And then brown. So orange again was 14. 13. Oh, Actually, I just saw I labeled that one wrong, huh? It should be 14. Let me change that above. So I had there. Sorry about that. So 14. We have blue, which should be 11. Red, which was 7. And green. I'll just draw them at the same time. So 7 and 7. Yellow was 3. And then brown was 2. And so the last thing we'd want to do is just, again, put the title up top. So color of M&Ms. And then also label your horizontal axis what we're looking at.